Hi, my dear students. Today we will continue our study of quadratic equation, and we have seen in the previous classes that the roots of the quadratic equation can be found by many ways, and we have already gone through to find out the roots of the quadratic equations by method of factorization and method of completing squares. By the use of method of completing square, we arrived at a result which is known as the quadratic formula, and this formula will give us a systematic root for the given quadratic equation by knowing simply the coefficients of the given quadratic equation. Here we have considered x square plus bx plus c equals to 0 is a quadratic equation where a, b, c are real numbers and a, the coefficient of x square, is not equal to 0, and on dividing the given equation by a, we will get here x square, here b by ax plus c by a equals to 0. And since in the method of completing square, we see the coefficient of x. Here the coefficient of x is b by a, so on multiplying this one by half, we will get b by 2a. So we need to add the square of b by 2a and subtract the b by 2a's square from the given equation. Here this b by 2a's square has been added and here is subtracted, plus c upon a equals to 0. In this context, these three forms will make a perfect square number, which is a binomial. Here is x plus the sign of coefficient of x is plus here, and b by 2a whole square equal to, just we are getting this to the right side, these two terms, we will get b square by 4a square and minus c upon a. On taking LCM of these two, we will get 4a square, and here we will have b square minus 4ac. Now here is a perfect square number. Just we want to have the value of x plus b by 2a equals to plus minus, since this is a quadratic equation, so it will have two roots. Here all the numbers written in the RHS are constant terms, so they will give a real number also, and we have taken this one. Those numbers may be the roots may be real or not real. We will decide those things later on in this chapter also. Here plus minus this, and x equals to minus b by 2a plus minus this, and the value of x finally we get minus b plus minus under root b square minus 4ac by 2a, which is known as quadratic formula. It was given by the greatest Indian mathematician Sridhar Acharya. Sridhar Acharya, most of the mathematicians also name this formula as the Sridhar Acharya's formula or Sridhar Acharya's rule to find out the roots of the quadratic equation. Here the two roots are one by taking positive sign, and another one is with negative sign. Here first root will be minus b plus under root b square minus 4ac by twice of a, and minus second root will be minus b minus under root b square minus 4ac by 2a. We have two roots. If we are given a quadratic equations whose coefficients or constant terms are known to us, we can find out the roots of the quadratic equation by using this formula, this quadratic formula. Okay. Just we can write the already calculated quadratic formula as also x equals to minus b plus minus under root d by 2a, where we have considered b square minus 4ac is equals to d, and the roots will be x equals to minus b plus root d by 2a or minus b minus root d by 2a. These two are the roots of the quadratic equation, or you can also put here b square minus 4ac. Okay, and the two roots of the quadratic equation can be found out by using this quadratic formula. And here the term b square minus 4ac is called the discriminant of the quadratic equation. This term b square minus 4ac is the discriminant of the quadratic equation. Hence, the nature of the roots, what type of the roots are, they will behave as real numbers, or they are not real numbers, they are rationals, or they are the nature of the roots will be discussed later on after having some examples to use the quadratic formula to find the roots of the quadratic equation. We will discuss this discriminant, the nature of the discriminant or nature of the roots of the quadratic equation later on. Now let us take a problem which is a quadratic equation, and we need to find out the roots of this equation by using the quadratic formula. Here, if you compare this quadratic equation with the original quadratic equation, whatever we have considered to find out the formula, here a equals to 5, b equals to minus 24 and c equals to minus 5. Now our job is to just put the value of a, b, c in this formula. You will get two roots. Here minus and b equals to minus 24 plus minus under root b square minus 24c square minus 4ac. Just I have only written the values of a, b and c here, and after solving we'll get the value of x as 5 and minus 1 by 5. The two roots of the quadratic equation has been calculated. This formula usually used, this is a very important, quite important in mathematics. In the field of mathematics, we use this formula to find the roots of the quadratic equation which are particularly not be factorized directly, or we have so many quadratic equation whose middle term cannot be splitted, or it will be very tough for us. Then we'll use the formula in such cases to find out the roots. Let's have one problem of like that. Here our question is to solve 2x square plus x minus 4 equals to 0. Here we cannot use the method of factorization to find out the roots of this equation. If you observe this, you can find the roots by using the method of completing square or by quadratic formula. Here a equals to 2 and b equals to, that is coefficient of x equal to 1, and the constant term c equals to minus 4. By using quadratic formula, we get x equals to minus b plus minus under root b square minus 4ac by 2a equals to all the values of a, b, c has been put here, and after that we find the two roots of the quadratic equation as these. These two are the roots of the given quadratic equation. Okay. So in future we'll use this concept of finding the roots of the quadratic equation broadly and go through all the problems in your book, whatever be the NCERT's questions, exemplars questions, or the questions from your reference book, that is the book of H.K. Das. So you are requested, you are directed to solve out all the questions as you can